Okay, so we would like to compute this integral, and this is a case where we have interesting things going in the sense that when we see an integral like this, it's not even obvious that we will be able to compute it, meaning we don't even know that the given function has a known antiderivative. But it does in this case. When I say known, I mean a function that can be expressed using known functions. That's what I mean by known. In any case, what needs to be done is we need to have the derivative, a substitution first. And the substitution is going to simply be u is equal to square root of x. That in general might be a substitution that we could be skeptical about whether it can be carried out or not. But it can, as we're going to see, and theoretically any substitution can be carried out. So du is equal to 1 over 2 square root of x dx. And this is why we could be skeptical, because we have the derivative, which is 1 over 2 square root of x, and there's nothing to be seen that in the integral that would give us a hint of that derivative. So what we do is we carry this over to the other side. So we multiply, in other words, both sides by 2 square root of x. And once we do that, then we have to make sure that we don't have any x's on the left. And of course, we know that square root of x is u, so this gives us 2u du equals to dx. And that's what I meant. I mean, the differential in this case becomes more complicated, but it's all about getting rid of the square root of x inside cosine. So let's see what happens here. So this becomes cosine of u, and then we multiply, our dx becomes 2u du, which means that, simply speaking, we can take 2 outside the integral, and we really have u cosine u du. And here we can do a simple integration by parts. We've seen such an integration by parts before. And we multiply with the derivative of sine. That's the same thing as cosine. So again, we think of sine, or we think of cosine as the derivative of sine. And that gets our integration by parts going. So first we drop the prime, and then we put the prime on the other function, which gives us 1. And this will give us 2u sine u minus the integral of sine u du, which of course will give us 2u sine u. And the integral of sine u is negative cosine u. The antiderivative of sine u is negative cosine plus c. Which is 2u sine u plus 2 cosine u plus c. And we shouldn't forget to go back to our original variable. So that's 2 square root of x times sine of square root of x plus 2 cosine of square root of x plus c. And that completes our integration. Thanks for watching.